What's up, Shibe Tribe, and welcome back to the best Astroneer theory series in the world, Astrolore. This is the third episode of the series, so if you haven't checked out the first two, make sure to do that before watching this one. Or not. I can't really control what you do. Before we start today, I need to elaborate on why this episode took literal years to come out. A lot happened in the time between the last episode and this one. I got really lazy. I got loaded with schoolwork and college stuff. I generally didn't have much time to work on anything, and I burnt out a little bit. If I'm being 100% honest, that is exactly what happened and why it didn't come out. Today, I will be fixing my math I did in the second episode, and then doing something pretty cool, which is fully classifying this system's star. This might be really easy or really hard. I actually have no clue how this is going to turn out. So without further ado, let's get started. So yeah, the numbers I ended up getting in my last video were actually like really wrong, but you can't knock me for trying as hard as I did. Now, I have the corrected versions right here, thanks to a little push in the right direction from System-Era themselves. Yeah, a few people from System-Era actually ended up watching my video, which made me really happy. So yeah, I have the actual real in-game engine sizes of these planets now. I may have done my math wrong, but we have a legit size thanks to my incorrect work. This is a win. Unless the sizes of the planets were like available before that video. I didn't actually think about that. Oh well. So one Unreal unit, as Adam and Google said, is 2 centimeters. The planets are about 120,000 Unreal units in radius, and the moons are about 60,000 Unreal units in radius. This is very simple math. We just have to convert those numbers into something like kilometers or meters. After doing this, I got the, actually I think it's canon this time, sizes of the planets, which was 2.4 kilometers in radius, 4.8 kilometers in diameter, and 18.1 kilometers squared in surface area. The moons were 1.2 kilometers in radius, 2.4 kilometers in diameter, and 4.52 kilometers squared in surface area. Bam! Done with the planet stuff now. Mission's complete. Now, time for the star. The star in this game may look like it can't be a real thing since it's so small and close to its planets, but I have a feeling something like this can actually occur in this huge universe for one reason and one reason only: the TRAPPIST-1 system. The TRAPPIST-1 system is a system that includes 7 planets orbiting a very small star. This star, classified as an ultra-cool red dwarf, has a radius slightly larger than that of our neighboring planet Jupiter, but it has 84 times Jupiter's mass. It's located 39.6 light years from Earth in the constellation Aquarius. And some other facts about this star that serve no purpose to this investigation, but are pretty cool, are its surface temperature is 2500 Kelvin, or 2200 degrees Celsius, or 4130 Fahrenheit, which is honestly not that hot for a star. Our sun's surface temperature in comparison is 5500 degrees Celsius, or 9941 degrees Fahrenheit. Also, I find it really cool how it's very similar in size to Jupiter. Kind of fuels that whole Jupiter is a failed star fire, which is a whole other can of worms that space nerds love to argue about, so we're gonna leave that one alone. Moving on. I'm not saying that the star in Astroneer is an ultra cool red dwarf. That would be stupid given the fact that the star isn't even red. Instead, I'm bringing TRAPPIST-1 up to show that systems like Astroneer are actually possible. 6 of the 7 planets in this system have orbits that only take around 1.5 to 12.4 days. This means that 1 year, or orbital period, on most of these planets is less than 2 weeks on Earth. While Astroneer's system is an exaggerated version of this, since, you know, it's a science fiction game about cute astronaut engineers, I feel as if I should have brought this neat little star system up. Also, on the TRAPPIST planets, it is theorized that you would be able to see its neighboring planets in the sky, similar to how Astroneer shows it. Okay, enough rambling about my favorite solar system. Now that we know weird stuff like Astroneer's solar system can actually, maybe, probably not exist, we can get back to the main goal of the video, actually finding a classification for this small white star in the center of Astroneer's world. Before we fully get into it, we need to learn how stars are classified in the first place. Stars are classified by a few key characteristics: color, temperature, size, composition, and brightness. A star's color gives clues about the star's temperature. The coolest stars appear different shades of red, and the hottest stars appear a bluish-white color like Rigel. Very large and chunky stars, like Betelgeuse, are called giants or supergiants. Our sun is a medium-sized, average Joe star, if you didn't know. Most stars are actually smaller than our sun, believe it or not. Stars also tend to differ in their chemical makeups. Astronomers use spectrographs to find out what elements are in each star. A spectrograph is a device that breaks the light into different colors colors. Scientists compare a star's light with the light produced by different elements to find out what elements make up that star. It's actually pretty cool and pretty simple. So a very bright orange color would most likely contain hydrogen, calcium, helium, and other metals. A bright blue star would contain different things such as helium, carbon, azote, and oxygen. Now, as you know the basics of star classification, let's get started. Since we know the correct size of the planets, we actually know the exact size of this star as well, since it's the same size as its planets. So, the star has a 2.4 kilometer radius, 4.8 kilometer diameter, and an 18.1 kilometer squared surface area. Alright, now we have the size and color. And since we have the color, we also have the temperature. White stars tend to be around 7,500 to 10,000 degrees Kelvin, which is hot. Moving on, there are only a couple more things we need to classify this thing: composition and brightness. Actually, I don't think we need these two, but we're gonna find them anyway. The composition is easy since we know the color and temperature. This star would most likely contain hydrogen. As for the brightness, I actually don't know how to do this, since most astronomers define star brightness in terms of apparent magnitude, how bright the star seems from Earth. I don't think we can actually find this. It shouldn't matter anyway. We can find the classification easily with the information we have now. The size of this star really slims down the choices for what type of star it could actually be. Not many stars have a radius of a mere 2.4 kilometers. The only stars known to get near are actually the smaller pulsars, neutron stars, or black holes, or maybe white dwarfs. White dwarfs are kind of a stretch, since the smallest one found is around 3,300 kilometers. So this star could either be a pulsar or a neutron star due to its size. It can't be a black hole since it's obviously not a black hole, and it can't be a white dwarf due to the size difference. Also, call me stupid, but aren't pulsars and neutron stars like kind of the same thing? It's just that one spins really fast and the other one doesn't. Okay, yeah, they're like the same thing. A neutron star only really becomes a pulsar once it starts, you know, pulsing. Neutron star, for those who don't know, are a celestial object of very small radius, typically 18 miles or 13 kilometers, and very high density, composed predominantly of closely packed neutrons. Neutron stars are thought to form by the gravitational collapse of the remnant of a massive star after a supernova explosion, provided that the star is insufficiently massive to produce a black hole. Gravity continues to compress it down to a point where the atoms become so compacted and so close together that electrons are violently thrusted into their parent nuclei, combining them with the protons to form neutrons, hence the name, neutron stars. Back to the main topic here. Almost everything lines up with this star being a neutron star. Its color, white, is close to the main color of a neutron star, blue. Neutron star surfaces are actually millions of degrees, giving them a very blue color. This star's size is actually really close to the smallest neutron star observed as well. PSR B0943 plus 10. PSR B0943 plus 10 is 2.6 kilometers in radius, while our star is 2.4 kilometers. I believe an ultra cool small neutron star is the best classification I can give this star from Astroneer. The most useful tool I had in my arsenal to find this classification was the size. Without that, I probably would have guessed it was a white dwarf, honestly. As for the question, how are 7 planets orbiting a neutron star, especially that close? My answer to that is, it's a science fiction game, and this is also possible in our universe. According to a study from the University of Cambridge and Leiden University, it is theoretically possible that habitable planets exist around pulsars, spinning neutron stars that emit short, quick pulses of radiation. According to new research, such planets must have an enormous atmosphere that converts the deadly X-rays and high-energy particles of the pulsar into heat. The planets that orbit around these neutron stars are known as pulsar planets. They are either formed by the remnant dust around the neutron star, or they could have been rogue planets caught by the star's immense gravitational pull. Also, there's a chance that the planet that orbits the pulsar could actually be the dead, cold core of a sibling star that got all of its energy and mass stolen by the main neutron star. As for life, it's highly unlikely anything could survive orbiting this close to a neutron star. The immense radiation and energy put out by the star would be too much for something as fragile as life to handle. So, it might be possible, but these planets would need a serious atmosphere to protect themselves from the deadly radiation, which actually kind of explains why Atrox is so radiated, and also that might give a true reason for the alien monolith structures to supply a strong atmosphere. Oh jeez, I gotta end this video before I go full conspiracy on you guys. I'll save that one for ASTROLORE 4. How about that? I hope you enjoyed the 3rd episode of ASTROLORE. This one was really fun to make since I'm a total nerd for star classification and neutron star stuff. Sorry this one was not too in-depth or complicated, it's just that the star size really made this classification take shorter than expected. I also want to apologize for the lack of ASTROLORE uploads. I explained why it happened at the beginning of the video, but just know I'm trying my best to get these videos out for you guys. Also, I am starting a series on Minecraft building. It's going to be called Shibe's Building School, and I hope to see you in class. Anyway, have a good rest of your day, and I'll see you next time. Maybe talking about some real lore of this game. I'm looking at you, Wanderer. See ya!